So in this video we're going to learn about another part about the triangle, which is called the perpendicular bisector. So the perpendicular bisector, you're same as before, you're going to have to draw and identify what it is. You're going to have to apply theorems about the perpendicular bisector. And then we have a new term, the circumcenter of a triangle, just like we had the incenter and the centroid before. Alright, so what is a perpendicular bisector? A perpendicular bisector of a segment because you only can divide segments in half, not rays or lines, a segment, line or ray, that divides a segment in half at 90 degrees. So to do that, we need to find the midpoint. So it divides it in half. And then we need to draw a line through that midpoint, or a segment or a ray, at 90 degrees. So it makes a right angle. So let's take a look at Sketchpad and what important theorem that happens when you have a perpendicular bisector. So in here I have my segment. So if I want to draw a perpendicular bisector, I need to find the midpoint. And then I need to construct a perpendicular line through that. Alright. So this is my perpendicular bisector, cut it in half at 90 degrees. We're going to put a point on this line, and can go anywhere, and we're going to measure the distance from that point. So the distance from A to B is 8.07 centimeters, and then we're going to measure the distance to the other end of the segment, and notice it's the same. And no matter where I move that point on the line, it's always the same distance to the ends of the segment. Alright. Let's go back to our slides and write down the theorem. So perpendicular bisector theorem. If a point is on a perpendicular bisector, so here's my perpendicular bisector, and I need to put a point on there. Let's do it in green. So there's my point. So a point is on a perpendicular bisector segment, then is equal distance from the ends of the segment. So here are my two ends of the segment, and I can draw alright. So those two blue lines I just drew are congruent. The perpendicular bisector theorem. So now let's apply it. So BD is a perpendicular bisector. Because it's a perpendicular bisector, I know this is congruent, and because of our theorem we just did, these two are also congruent. Well, then I can use that to find AD. Well, since these two are congruent, I can set up the equation 3x plus 14 equals 5x. To solve it, I'm going to minus 3x, do our algebra skills, it's 14x, divided by 2, x comes out to be 7. Alright, so x is 7, but that doesn't really answer the question because I need to find the length of AD. Well, the length of AD is 5x, so instead of x, I'm going to plug in our 7. So it's 5 times 7, which is 35. That is my answer. So on the diagram before, JK is the perpendicular bisector of NL. So we're bisecting NL, so I know that is congruent. And you can actually look at the first question, which segments are congruent. Our segments would be NJ and JL are congruent. That is one pair. And these should have lines above them because they're segments. The other pair, well, since it's a perpendicular bisector and K is on that perpendicular bisector, this is congruent. And then notice we have two 8s, so they are also congruent. So I can list my pairs. We have MN and ML, and we have KL and KN. And again, all of these need the little segment sign above them. Oop. Now we need to find the length of NK. Well, these two are congruent, so it's just like above, where I'm going to set the two equations equal to each other. So 6x minus 5 equals 4x plus 1. I'm going to do really quick algebra here. Minus 4x from both sides. Add 5. I get 2x equals 6. Divide by 2. X is 3. Well, since x is 3, I now can find NK. Again, you're not done there, so I need to put 3 into there. So 6 times 3 minus 5 gives me 13. So my answer for this one is 13. Explain why M is on the line of JK. Well, JK can be extended, and you can see it's going to run through M. But more importantly, change colors, we have two congruent segments, which means for them to be the same distance, M has to be on the line of JK, just like we know these two are congruent because K is on the perpendicular bisector. Alright, so then you have something called the circumcenter of a triangle. This is the point of concurrency of all the perpendicular bisectors of a triangle. So I'm going to pull up Sketchpad so we can see the theorem down below. We are done with this one. Alright, so there we go. Here is my triangle, and to get this, I found the midpoint of each side and made perpendicular lines just like I did in the other construction, and notice all three intersect. Now, because these are actually three segments that make up the triangle, the same theorem applies. And since this point, our circumcenter, is on each perpendicular bisector, we're going to have the same situation happen. So if I measure all these distances, notice it is equal distant from all the sides of the triangle. Right? And as I make my triangle bigger or smaller, what happened here? Oh yeah, never mind, it's working. For a second I thought it wasn't working. Yep. See, as I change it, they all equal the same. Alright, I can move either side. Now notice, my circumcenter does not always stay inside the triangle. It can move out, depending on what type of triangle you have. Alright. Sometimes it's actually on the triangle, sometimes it's on the outside, and then when it's acute, it's on the inside. Alright, and then the other important thing, because all three of these are equal distant, circumcenter means it's a center of a circle. A circle circums a triangle. So as I move my triangle around, the triangle is always on the outside of the circle, even though my center may be out. And then the circumcenter is the center of that circle. Alright, so let's make sure you have the theorem written down. So down below, you have this theorem. The circumcenter is equal distance from all the vertices of the triangle. So really just applying, so if your circumcenter happened to be in here, it'd be the same distance from all of them. And actually I think the circumcenter is down below the triangle. Right? And then this also allows us to make a circle. Now we had the one before where you draw the circle inside the triangle, and this is for when you draw the circle on the outside of the triangle. Alright, so the circumcenter can happen in, on, or outside the triangle, which is what I showed you. So in, when it is acute, when it's a right triangle, it's actually on the triangle. And then when it's obtuse, it's on the outside. And again, it's called the circumcenter because a circle can circumscribe about the triangle. You can draw a circle around the triangle. Right. So one last example, we're going to find these lengths using your circumcenter. So we have the information here. So first we need to find the length of AG. Well, AG is your circumcenter. So, and we already have one length to one vertice. So that means this, and this, AG, BG, and CG are all the same length. So AG is 25. And I notice down below we have BG, so I can also write that as 25. Right, so then we have CF. Well, F is the midpoint of the triangle, so CF has to be 24. If this is 24, that is 24. Same, we have another midpoint. E has to be the midpoint for us to create our circumcenter. And then, so that is 15. And then BD, same thing, would be 20. And then AC, which is the entire length of the bottom, would be 24 plus 24, which would be 48. Alright, that is it. So that is your perpendicular bisector. Remember, if you need perpendicular bisect any point on there, it's the same distance from the same distance from the endpoints of the segment. And then you have your circumcenter, which is equal distance from the vertices of the triangle, and then you can also draw that circle. Reminder to do your reflections to get credit for watching this video.